Hi folks, this is a tutorial video showing you how to get Concorde loaded with a custom flight plan which can be followed by the CIVA INS. It will also be followed by the ordinary FMC. I'll show you how in the flight. This is going to be from EGELL Heathrow London to JFK in New York. We've already got the aircraft departure set as standard. We're on 27 right, ready for takeoff. And to add the custom flight plans that are included with Concorde, we just hit space and then space again, and we can load from this PC. You can also load from Xbox. The flight plans are included with the aircraft in its documents folder. I'm just going into my Concorde aircraft folder anyway here, but there'll be different ways of doing it depending on where you've actually got Concorde saved, whether it's in your main flight sim folder and so on. But it should look the same as this. And there's flight plans, London to JFK. And it'll load that up, and you can see there that this is a custom flight plan. It's been designed, the INS itself has been designed and coded to follow as few intersections as possible because it had a maximum of 9, just like the real life CIVA INS. Now you can enter them manually, you can get halfway and then add some more to detail the flight, just like the real Concorde would have had to do. They'd have to update it during their flight, but we've set it up this way so that you can just go straight off and be within the 9 limit on the CIVA INS. So we're all good. We're in real world weather. So I'll hit fly. Wait for the sim to do its thinking and get everything ready. This tutorial is going to cover all the basic procedures. The flight's going to be sort of broken up. It's obviously a 3-hour flight, so I'm not going to record the whole 3 hours. So this video is going to be a series of sections. It won't cover the descent and landing, as that's obviously the back end of the flight. The problems that most people seem to have with Concorde is takeoff, climb out, fuel transfer, reaching Mach 2 when Concorde can do it. It can't always. It's a mistake a lot of people make. They think it could just do it all the time, and it couldn't. So we're on the runway, and we're just gonna. I always do this. The lights are often on at the runway. Let's cover the engineer's lights. So I'll just turn off the FMC for now because we don't need that. So first things first. We need to get these active. The MCU for the INS is here. You simply switch to nav. And you'll see here now it's alive. And what you do is you hit remote on, loading flight plan loaded, remote off, switch to auto. It's now set from flight waypoint 1 to waypoint 2. Showing up on the HSI. I normally set this to position, going from 0 to 1 there. So, series of set jobs you do in any aircraft. 0 the altimeter to local air pressure. I'm also going to set up the autopilot. Get ready so it can take over after takeoff, and that'll give us our starting point. 250 knots will do. We'll set first for 10,000 feet. Give the controls a full and clear. Now Concorde, obviously, there's 2 things you need to look at here. The checklist will cover everything, so you don't have to watch this video. It's all there, including fuel transfer, climb, methodology, takeoff, the whole thing. We'll look at that later as well, but for the start off, we need fuel. What we're going to do here, skip over here. Now a lot of people panic over this panel It looks horrendously complicated. It is very complicated in many ways, but really it's just a picture of Concorde from above. There's the forward tanks that transfer fuel. Here's the rearward tank. So obviously as the fuels move back and forwards, it changes the centre of gravity, which is marked here and here. Engine feed tanks, 1, 2, 3 and 4, always over full because they're constantly being fed. And the other extraneous fuel tanks, all of which can be moved around. So you can move fuel anywhere you want. So what I always do, pop that to maximum to start with. Obviously you're overfilled at the moment. Rearward trim transfer, you see as I reduce that down, we'll put that at 50%, it's lowered the amount of fuel there. 94%, 401,000 pounds of fuel. So we're inside the maximum, we're all clear, and we'll leave that as it is for now. Move back to the front seat there. That was just to show you the fuel panel and how it responds to the fuel tanks. So we're kind of almost set. Just a few jobs left to do now. Get the engines ready. We're going to need reheat for takeoff. We're heavy, full of fuel. Total fuel on board, 90,000 kilograms, 90 tons of fuel. Going to leave the stick invisible for now so I can see the instruments clearly. Everything's set, altimeter's ready, C of G just outside limit, that's okay for takeoff, that's what we want. Trim set. Gonna run the engines up. Releasing the brakes, maximum burner, that's full reheat. I'll get this show on the road, get the aircraft airborne, cleaned up. Autopilot engaged, and then we'll start the business of monitoring the climb out. Keeping on the centre line, a little bit of left rudder, a little bit of crosswind there. Looking for 170 knots, 160, 170. Stick fully back, waiting for the nose to rise. There she goes. Easing the stick to centre, positive climb, gear up, out of afterburner now, all burners off, auto throttle on, airspeed acquire, autopilot on, altitude acquire, and heading hold. That will then set us in with the INS. You can leave the throttles alone now. We're acquiring altitude, checking the airspeed, 240 knots at the moment, and we're going to raise the nose. Makes the cockpit somewhat quieter. We have got cloud about, so we're going to put the de-ice and de-mist on. Now watching this, we should be counting down. Just waiting for it. 21, yep, we're counting down. So it's tracking inbound onto our first waypoint. HSI is showing in reverse at the moment because we've left Heathrow going from 0 to 1. That will flip around in just a bit. Okay, so airspeed's good, climb rate's good, quite high, 3,000 feet per minute. The autopilot is controlling that. You see it's lowering down now to make it easier on the engines. So far, so steady. Now you could, if you wanted, if you didn't want to use the INS, if that's a bit too much for you, you can turn the FMC back on if you want to use that. It's always visible there if you need it. And you would simply switch to INS, and that will track the exact same flight plan, but more in the manner of a modern flight autopilot. Because an INS is not really an autopilot, it's following a set of coordinates. This one does act a little bit more like an autopilot to make it a little bit more manageable, but that's not its real function. So, everything going good, everything's tracking okay. Concorde would normally clear to about 400 knots now. You can see here this barber pole and the airspeed indicator is just above 400. That's our maximum velocity below 10,000 feet and below a certain Mach number as well. So we're just going to push that up a bit now to 300. Concorde will automatically lower the nose to allow the engines to pick up the airspeed and then reassess before raising again. And this is all a combination of the standard flight sim autopilot and custom coding to more mimic what Concorde would do because it's so unique. Coming up to 10,000 feet now. We're going to push that up now, 20,000. That's the altitude we want. We leave it on altitude require. Concorde will balance itself and take care of everything. Still tracking the INS, everything looking good. (10,000 feet now, so we can shut off the landing lights. And we're steadying the climb. As you can see, we're still on indicated airspeed, Mach 0.55. Concorde did not accelerate straight away to Mach 2. It would take often beyond an hour, sometimes 2 hours, to reach Mach 2. It all depended on air conditions, fuel weight, meteorological factors. Summertime, it's very warm over the Atlantic, even in the troposphere right up high, and Concorde just couldn't make Mach 2. It didn't always do it. It'd be like Mach 1.97, Mach 1.98. It might eventually reach Mach 2 and flight level 600 very much towards the end of the flight when it's much lighter and it can climb that much better. So Mach 2, flight level, 60,000 feet, it obtained that sometimes. It did not obtain those figures all the time. And that's the most crucial thing to remember. It's what it was capable of, not what it did all the time. So all tracking well here. You notice the HSI is often tracking off beam. It's because this is picking up every waypoint between EGL, Heathrow and JFK London, JFK New York. And what it does, the INS, it skips all those in this coding to just track onto the next actual intersection, keeping it under 9, as I mentioned earlier at the flight planning stage, so that you don't have to keep re-inputting lat long coordinates. If you switch to manual, then it's on automatic at the moment. If you switch to manual, you would then have to do that. You can type in your own coordinates, input them, and adjust as required. Push the speed up again now. 350. CFG is balanced, looking good. Just over 5 degrees angle of attack, that's acceptable. This is affected by CFG as you sweep it further up. You can still make New York without doing it, but it'll be much more efficient, Concorde, if you do make the effort to move the fuel. See, we're not using afterburner, that's all switched off. Reheat lights are out. Almost there now, almost flight level 240. That's the levelling off altitude. Concorde would normally level off at 240, wait until it got over the Bristol Channel for sound reasons before it would then accelerate to supersonic. We're going to do it a little bit earlier. While we're waiting, I'll just show you the checklist. Crucial things, yeah, fuel transfer rearward. You can follow this process. Okay, 59% is what you'd have about Mach 2. Climb 24,000, we'll be climbing to 45,000 under auto throttle. You can also do it manually, turn your auto throttle off and go to full afterburner manually. Auto throttle on just saves you the job. Altitude acquire to start with, then max climb. That tells the autopilot to acquire the altitude, and then max climb controls a balance between attitude and thrust to keep the aircraft within speed limits so it doesn't over accelerate or overspeed. Preheat, of course, are all on, we'll need those. Throttles to full power, and that carries on then all the way up to 45,000 feet, Mach 1.7. At that point you can turn all the reheats off, and then you start to climb gradually to flight level 500. Above this altitude, max cruise will auto engage, and then you go through the following processes to stabilise the cruise. Once you're in the cruise, it's a slow climb to flight level 600 as weight reduces. Max cruise engage if not to engage. Seek Mach 2 if possible, and it will do so depending on weight and atmospheric limits. And if the alarm sounds, you're either too fast, 2.04 is the maximum, or your nose temperature is too high. At the moment it's fine. Anything over 127 degrees centigrade and the alarm will go off. I see a lot of people cruising at Mach 2.3 or whatever. Concorde's physically capable of it, but it wasn't designed to do it. 2.04 was its maximum, and that's where you needed to be. So, for the sake of convenience, we are at 240 and we're ready to go. We're not yet over the Bristol Channel, we're still over land, but for the sake of this video, we're going to do things straight away. So, altitude hold. Now we adjust. Ready to acquire the altitude. We're going to start moving fuel shortly. We're already at Mach 0.8, holding 350 knots as requested on the auto throttle. We could have pushed it up further now because we were capable of 400, but I've left it there. Burner switch is open so the autopilot can use the afterburner. We're ready to go. Everything's looking good. The tracking, we're where we should be. So altitude acquire, first of all. Nose comes up. Now max climb. What it'll do, it'll come back down again. It'll look for 400 knots or close to, accelerating, and then it will climb automatically. It will move around depending on how much thrust is available. Yeah, if it starts to slow down, it'll be climbing too steeply, so Concorde will automatically drop its nose, and it will do this all automatically for you. It's doing it now, taking care of business all on its own. Sometimes you'll only see 500 feet per minute climb rate. In fact, later on it probably will drop to that. Airspeed's increasing. Confirmed in Mach climb, so it's time to get back here and take care of business on the flight panel. As you can see, we're just coming out of tolerances. The way I do it, you want to switch your fuel auto transfer to rearward. Set a maximum transfer at any one time, 5 tons. You want to move the fuel as far forward as possible to as far back as possible. So set the pumps to auto because we're on automatic, and on the back, auto, auto, and open the valves, and that's it. And you should immediately start to see fuel transfer. There it goes, creeping up. Fuel will empty from this tank, there it goes, and increase in this tank, thus shifting the centre of gravity balance, and you can just leave that running and it will do it all for you. You are able to also move fuel from these tanks into these tanks. Again, same process really, just opening valves, telling the fuel where you want it to go to keep moving stuff further back. And eventually, when you're at maximum Mach, you want a COG balance of 59. There's a very slight discrepancy at the early part of the gauge readings. The code's correct, the math's correct. I haven't figured out why, but once you get to about 56%, it's very accurate. So it just seems to be an MSFism of some kind, I'm not sure. I'll keep working on that. But as you can see, it's moving back steadily, catching up the Mach number gauge there. So we'll go back to the front seat. And keep monitoring. There we go, burners are in. You can usually tell by the fuel flow and the noise. But put simply, it gets noisier, and obviously you have 52 tonnes per hour, 48 to 52 tonnes per hour. So it looks like you haven't got enough fuel, but this is where the magic is. We'll keep accelerating, just hitting Mach 1, there we go, just hit Supersonic. And what will happen now is we're almost reaching the speed limiter, the barber pole there. We're over the Bristol Channel now. And Concorde will then use attitude to control airspeed. So in full burner it will climb as quickly as it can. As we get higher, the maximum enabled Mach number and indicated airspeed will increase. And thus Concorde will read that and keep pushing us up to speed. And this is the reason we have the afterburners on here, is because this is what's called the high drag area of the flight regime. Concorde has to push through from here to Mach 1.7 and flight level 440. Once it achieves that, it will no longer need afterburner. It will be going fast enough and the aerodynamics be working in the correct way, and it will mean that the aircraft can then stop using afterburner. So you level out 440, turn off the afterburner switches, the reheat switches, and thereafter it will climb just using dry power, but obviously at a much reduced rate because of the much reduced thrust. So you're really just monitoring now. You can see the autopilot, the INS following the correct route because we're following the Bristol Channel out over the water. When you use the FMC, the HSI will actually follow the course much more accurately, visually as well. You'll see the HSI bars line up, and you're tracking outbound to each and every intersection. Here the INS is just doing it on longer ranges. You can see the readouts, 43 nautical miles out, 42 now. And here's another interesting one for people who want to learn. 422 knots indicated, but look at this, 667 knots ground speed. That's because even though we're accelerating, as the air gets thinner at higher altitudes, indicated airspeed readings reduce, but ground speed increases. That's the difference between ground speed, Mach, indicated, calibrated airspeed, true airspeed. They're all different depending on what you're trying to measure. That's the one you would measure our ETA into New York on. Fuel's moving back nicely now. Getting out over open water as well. We're in real weather, by the way. It's actually a sunny day in the UK for once. I'm just going to correct the altimeter again to local barometric, so it's dropped away a little bit there. So we're in a lower pressure area than we were at Heathrow when we took off. Okay, see how the Mach pole now, the barber pole has moved to 450 indicated as we're higher, therefore we can increase the Mach. Climb rate is reduced to 500 feet per minute, and as we reach the required speed limit, it then eases up gradually. It's controlling the nose. The real Concorde did this not just in the climb but also at altitude. It would dip up and down to seek the most efficient airspeed and the most efficient altitude at all times. As you can see, we're 25 minutes into the flight. This is actually quicker to altitude than real life, because as I say, Concorde would have waited to get over the Bristol Channel and it would have done a shallower climb, probably only 1,000 feet a minute. Nice low throttle setting, 400 knots maximum, and then arrived at the Bristol Channel right on 24,000 feet, ready to accelerate supersonic, and that would have saved some fuel. So we're doing it a little bit inefficiently here just for the sake of the video, at a much higher climb rate out of Heathrow. Okay, so COG looking good. We'll go and have a look, but I suspect the rear tank is now full. Yes, it is. 10,500. 10.5 tonnes in the aft tank. It's not going to go any higher than that, but we'll leave it in auto because as fuel does eventually drain from here, or we choose to move it to different tanks, perhaps these ones or these ones, then we can push that CFG further aft. You'll see it actually reduce over time, but it's much more accurate now, very close to what it should be. If you're particularly worried about how super accurate it is, then just rely on the digital gauge, because that reads direct from the sim. This is animated, so there is a slight discrepancy there. Not much else to do there for us at the moment. Burners out there, I think, at the moment. Yeah, definitely burners out. It's not needing them at the moment as much. Reduce the climb rate, Mach 1.3 just coming up. And again, it's now much further, about 480 there, maximum indicated. That's given us a Mach of 1.3, probably 745 knots ground speed now. As you can see, it's not a rapid process. It takes time, it takes patience. You do have to follow correct procedure. If you get it wrong, I've seen so many messages from people who said Concorde's never reached Mach 2 for me. You know, the product's bugged, it doesn't work. They just don't do it right. There's videos on YouTube from reviewers from when Concorde launched back in 2022 showing Concorde at Mach 2 and 50,000 feet plus. It's been able to do it since it was launched nearly 3 years ago now, 3.5 years ago now. So it's just procedure, that's all it is. And as you can see, it's automated. You know, if you don't want the difficulty or the extra workload of doing it all yourself, obviously you've got to do some jobs, but it really does most of it for you if you want it to. See climb rate now coming right down, going up again now. It was at 600-700 feet a minute, going down again. So it's all being done with the nose. It's just adjusting gradually. You just about see it moving up and down, constantly balancing. it's not doing it with throttle, they're fairly stable. It's all about attitude. It's funny if I switch to INS, yeah, there you go. So you can switch back and forth the INS, and that shows you the actual track. So the INS doing all the work here, using heading hold. It wouldn't normally do that, it would actually be INS in Concorde in real life. This is used for here, it's just an imitation of MSFS basically. INS is the one you use if you're on the FMC, and heading hold for the CIVA INS. Those controls, those features are also listed. Yeah. So you've got various instructions here in the checklist to let you know about which part of the navigation system you use and where to find them, of course. Various buttons that you might want. So INS switch, it lights it up for you. INS engage, flashing there, see? So you just select which one you want, and there's also details in the written manuals which you can find in the same place as the flight plans, in the documents folder if you want to read up on it a little bit. And I also included the actual real life manual for the CIVA INS, so that if you wanted to manually input your lat long coordinates for flights, you can follow the actual procedure. Big shout out to Big Radials for this. I did not code this, Big Radials did, in return for work that I did for Big Radials last year. You know, it's a great thing. Aussie at Big Radials, he's a much better coder than I am, HTML, so he did that. And I did, it's the same one that's in the Jetstar, the Big Radials Jetstar, another great airplane, and just adapted for Concorde. And it's just a great example of developers cooperating with each other, helping each other out. We do it a lot. I don't think I could have coded that myself without assistance, so it's been awesome. So where are we at now? Mach 1.5, just coming up. 40,000 feet, still afterburner, still reheat. Good rate of climb. Just looking at the temperatures outside. It's a bit colder now than when I last did this a couple of days ago. So we might well get to higher velocities a little bit easier. You see the Mach gauge is now moving just outside. Just outside parameters, so I might have to move a little bit more fuel, so I'll show you how to do that for those that really want to give it a try. Obviously this tank is full, so we'll shut the valves here. See they shut now. Pump auto, we're still moving fuel aft, so we should be able to open the valves. Yeah. Just monitoring that now. It'll be slower. Yeah, 56.7, so that's climbing now. We're sending fuel from here to these tanks. So it's not as far back, so it's not moving as quickly. But it's emptying fuel out of that front tank to keep this moving. So it's an extra function. And it'll keep filling these up. And remember to come back to that in a minute. Once you've got 59, of course, you're done then, so you can leave it. Okay, Mach 1.6 just gone, wobbling about there, probably because of the air outside. up to altitude now. And this is where Concorde's aerodynamic magic works. As we reach altitude, the aircraft will come out of burners, already is, on a lower fuel burn now. Lights are out. But we're still accelerating. What I'm going to do here, just give it a couple of 3 extra 100 feet. Check the INS, yeah, we're on waypoint 4 to 5 now. Oh no, 5 to 6, just changed, that'll be the turn. We're at altitude, Mach 1.65. Pretty sure we can remove these now. Climbing a bit and still very gradually accelerating. So we are now super cruise, just coming up to Mach 1.7. Now what we do is very gently to let Concorde start going uphill again. Turning at the moment just to settle into the coast of Ireland now, I believe. Yeah, we are still accelerating, so we've got some room for manoeuvre here. Oh. Flight level 5-1, and the reason I picked that is that max cruise would engage above 50,000 feet. So I'll give it the extra 1,000. It doesn't have to be 1,000, it could be 500 feet if you wanted to. And that will move us up. Yeah, we're still gradually accelerating. The wobbling is usually due to turbulence outside the aeroplane. Head back and check on that fuel flow, because it looks like they filled up the tanks. Shut those now. Try and push that further back in a minute. Mach 1.8 coming up. No afterburners now, no reheat. Angle of attack just down to 1 or 2 degrees now, so we're quite efficient. Climbing at 1,000 feet per minute, that's a good rate of climb. You don't always see that. Normally at this altitude, this far into the flight, in the last week or so, you know, maybe 500 feet a minute if you're lucky, sometimes as low as 200. Again, entirely dependent on how cold it is outside, what the conditions are, even headwind. You know, how much headwind's coming at Concorde might make it difficult. But this is pretty good. Let's see what else we can do with that fuel then while that's going on. So it's a management job, constantly managing what's going on. Concorde's not a simple aeroplane to fly, so I think we'll just settle these to auto. I'll open up the valves again. And see if they'll push some more fuel back soon. Wondered if we open these as well. fuel will flow from both tanks going aft. Might be interesting. Full basically, aren't they? No, doesn't want to override it at the moment. Full is full by the looks of it. Trying to get that CIVA as far back as I can. No, it's not moving for now. So we've done all we can for the time being. We'll shut those off, but we'll leave the centre open for rearward flow for the time being. Okay, barber pole's at the maximum now. Wobbling around there, Mach 1.92. Almost at altitude now. I've just realised this whole video has gone in one section. But that's probably the best way to do it, I suppose, because you're seeing the whole thing without any breaks. So now it's just a waiting game. You can actually see the turbulence. Concorde rocking gently there, look. That's causing the wobbling. Climb rate has actually dipped. We're now coming back down. Concorde is too heavy. We can't go any higher. And we can't go any faster. So it's auto holding at the most sensible altitude based on the conditions. Again, exactly like Concorde. It's a perfect. I'm glad that's happened. Perfect example of how you just have to wait. We're 41 minutes into the flight, and Concorde's reached about the spot where it's kind of now just in a very gradual, very gentle climb. Just a little bit of gain. 24 tonnes per hour fuel burn. Basically something under 3 hours of fuel. That will reduce as time goes on because we're still in a climb a little bit. That gets down to sometimes about 12 tonnes per hour. So you can see, and as we get higher of course it will get better and more efficient. I'm not sure how long it will take now. The conditions are such that Concorde is sort of just balancing itself at the moment. So it will step climb gradually up to altitude. We've still got a bit of fuel to move aft as soon as I possibly can. But I think that pretty much covers it. Mach 1.93. As you can see, we're in super cruise, so it's now just a waiting game to gain the altitude, which as you gain altitude the Mach number will increase anyway because your indicated airspeed, or your ground speed rather, will increase. Indicated airspeed 620, but our ground speed 1091 knots. So we've probably got 2,500 to go, so we're approximately 2.5 hours away from New York now. And again, as we go higher, that will increase, so our ETA will reduce. We're very, very close to Mach 2. It's edging its way up. A lot of turbulence. Been a rough flight if this is real life. Yeah, no climb at all. Okay, I'm going to leave that video there. I'm going to turn that off now because it could be another half an hour before we actually make Mach 2 and the desired probably 54,000 feet with a gradual climb up there over the next hour all the way to flight level 600 if it makes it. Sometimes it didn't. So a good bit of good fortune there that's actually showing you how the autopilot will control where Concorde can get to and won't allow it to exceed its parameters if you're using the airplane correctly. When you do eventually go through 50,000 feet, max climb will go to max cruise, and it does it automatically, and it will then just attempt to maintain that same kind of balance while gradually increasing height as the fuel weight comes down. Okay, I hope that's been helpful. Any questions, revert back to the manual, post a question in the comments. I'll try and answer as many as I can, but most of what you see there is what's required. And of course on the other side of the flight, it's just the descent down to wherever it is you're going to land, which you would commit to something like 200 nautical miles away from JFK. So, and you would switch over then to radio nav, or you track the INS down until you can pick up the ILS for JFK and switch over at that point. Okay, hope that's been helpful. I'll see you in the next video.